Hello, folks, and welcome back to this time we're looking at yay, change of pace. We're no longer doing chapter 2, it's chapter 3 time. So let's get to work. We're going to be talking about the derivative of a function. And before anybody starts freaking out, don't worry, you've actually seen most of this before. So let's get started. The derivative of the function is going to be this lovely expression up here, which once again, wait a second, you've seen this before, so it shouldn't be terribly earth-shattering. The only thing that's notable is I'm now officially saying that that is the derivative of the function. Now, you indicate the derivative by having an f with a tick mark after it. It's called f prime, and all you're doing is you're saying that that is the derivative of the function, provided that we do have a limit there. Go ahead and freeze this, copy this down, and yes, this is something worth adding to your notes. And time's up. Let's move on. Next, if we have f prime of x in existence, we say that the derivative that has a derivative, and we use the term a lot, differentiable at x. It means I can take the derivative there. And then any function that is differentiable at every point, we call a differentiable functions. Most of the things we're going to deal with for our purposes in calculus are differentiable functions, so I wouldn't worry too much about that. Next, we're going to put this into practice, and hopefully this should look familiar to you because we're now going to find the derivative of this function in here. So let's see what we can do with that, and let me switch to this format, and we're going to say that it's going to be the limit, whoops, the limit as h approaches 0 of f of x plus h. Now, just as a reminder, x plus h means that I am going to substitute x plus h into each of those, in the place of each of those x's there. So when it comes to finding x plus h, I'm just going to say that it's going to be negative 16 x plus h quantity squared plus 96 x plus h. Okay, that's my f of x plus h on that one. Next, I am going to find f of x, which, oh wait, that's just this here. So all I need to do is subtract that expression. So I'm going to say that's going to be a negative 16 x squared plus 96x. And then I just stick that whole thing over h. Now, at this point, the calculus is done. All we need to do is a lot of algebra to try and simplify this mess. So I'm going to say that I've now got the limit as h approaches 0 of negative 16. Now remember, x plus h quantity squared is going to be the same thing as x squared plus 2xh plus h squared. And I'm going to distribute that to give me 96x plus 96. Wow, that is awful. 96h. And I'm going to distribute my negative to give me 16x squared minus 96x. That's all going to go over h. And I just need to distribute this 16, which is going to generate the following stuff here. Okay, negative 16x squared minus 32xh minus 16h squared plus 96x plus 96h plus 16x squared minus 96x. And that's all over h. Now, next thing I want to do is I would like to clean this stuff up. I'm going to do that by canceling what I can, which is the negative 16x squared and the positive 16x squared. and I've got a negative 96x here, and I'm sorry, a positive 96 and a negative 96 there. So what I am left with now is going to be limit as h approaches 0 of negative 32h minus 16, okay, plus 96h all over h there. Okay, and it still looks like a mess, and if I do my direct substitution, once I get 0 over 0. So what I'm going to do instead is I can see that I've got a GCF of h up there in the numerator. So let me factor out an h, and I can factor out that h, and I can factor out that h. And now I'm going to cancel this h with this h. So I'm now looking at an expression that's much simpler of the limit as h approaches 0 of a negative 32x minus 16h minus 96. Sorry, that should be a plus 96 there. Okay, and now the only thing I need to do is I need to substitute my value of 0 into my h, which should get me down to a final statement of negative 32x plus 96. Okay, and so there's my answer for the derivative of my function. Now, if all went well, I should be able to find something similar to that in my original presentation. So let's go to there and see. And I say, let's check it out. And what do you know? I got the right answer. Yay me. Okay, next, let's do something a little bit different because this is all review. Let's do the stuff that's a little bit new here. First off, the derivative of the function, here is what is called the alternative definition. And I need to point this out mostly because there are going to be times where this is a little bit easier. Now, notice you've got it written as an A here, and there's an A there, and there's an A there. All A is some sort of value. Don't know what the value is. It probably changes. It's not a big deal. We're just going to do the problem with, instead of having A, we'll just use the value. Okay, and the next thing I'm going to need to point out is we also have a bunch of different ways of expressing it. So you can see here that we've got, well, what I've already showed you, which is y prime. Okay, that means the first derivative. The next one is going to be dy dx. That is going to be seen very frequently, and I know at least initially many people are not going to be thrilled about that because it takes more writing. But it is a really good signaler and doesn't get as lost. So in some cases, this is going to be your preference. df dx is almost never used for our purposes, and you can't see it, but that actually says d dx. So it has like d over dx of f of x. And that's not earth-shattering. It's just another way to write it. So let's go back to the alternative definition. Let's do an example with that. And let's see what we can do with this here. Okay, it says find the alternative definition to find the slope of the tangent line to the graph of f of x at this here. Okay, give you guys a second to copy this down. And now I am going to switch formats again. Okay, come on. And here we go. And I've copied it once again into this. So how do you go about doing this? Well, what we're going to say is, once again, we're looking at the limit as x approaches 5. And I'm going to say, all right, well, remember it was f of x, which in this case is x squared, minus the value, or f of x at 5. So that's going to just be 25 there. And then that's going to be over x minus 5. Okay, once again, if I do write direct substitution, it doesn't work out too well, but what I can do instead, of course, is factor this expression and just say that the limit as x is approaching 5 of x plus 5 times x minus 5 all over x minus 5. Oh, that makes me much happier because now I can just come in and cancel those two. So all I'm really looking for is this. What is the limit as x approaches 5 for the expression x plus 5? Well, I'm really hoping that everybody is able to quickly get an answer of 10. So that's going to be the slope of my tangent line. Well, I'm trying to find the slope of the tangent line. Looks like I've got it. Let's switch formats again and see if we can get there on this. And, ooh, I'm hoping, did we get the right answer? Yes, we did. Cool. Okay, well then, ladies and gentlemen, let's change gears one more time and say that we are now going to move on to exit slips. Dig in, have fun, and I will see you in class.